try to finalize 9 years of work. What I mean by that is we're trying to transition Web Audio API specification into something called recommendation. Recommendation is the final stage of the W3C spec document. That means it's the end of a version 1 Web Audio API. So it's going to be frozen, and we're not going to work on that anymore. So if we have to add more new features on that, it's going to be Web Audio API version 2. So that's very exciting news for all of us, I think. So to sum it up, literally like 2 questions. What happened for the last 9 years? And what's next for us? So before we start, I'd like to clarify this retrospection is just purely my own opinion. So if you find anything inaccurate or problematic, please feel free to reach out to me after the presentation. I'm looking at you, Chris, actually. In the grand scheme of things, I believe it's better to split this entire timeline into 2 phases. The first phase is from 2010 to 2015. So let's talk about what happened in 2010. September 2010, Chris Rogers, who pioneered this whole Web Audio API project, landed the first patch in Chromium. And that patch includes the implementation of audio context. If you're aware about Web Audio API, the audio context is the mothership object of all the Web Audio API operation. And Blink fork from the WebKit actually happened in 2013. So actually this patch, this commit predates the Blink fork from the WebKit. So all the changes he made in Web Audio API back then, we could see the same thing is happening in the Safari and Chrome at the same time. That was a good time actually, because we didn't have this different implementation or fragmentation between Safari and Chrome, but now we have, right? So that's a kind of problem that I'll talk about later. But here's an interesting bit. In 2011, that's when actually the actual spec discussion started. So we landed the implementation in the browser first. Then we started the spec discussion. Isn't that a bit weird? So I actually went back and dig through the mailing list in the audio working group. It dates back to 2011 March. So the official working draft of the spec was published in 2011. Yeah, it's kind of weird. This is something we cannot do today though, because we have a really a feature launch process. Now it's set in place, so you have to go through a certain steps to launch a feature in the browser. So without any kind of working draft or a kind of a general consensus in the working group, it is almost impossible to launch a feature in the browser these days. Am I speaking too fast? Good. Then it is followed by the Web Media API. The first commit of a Web Media API spec happened in 2012. I actually did that, so it's in GitHub. Interestingly enough, Chris Wilson over here sent out the intent to implement email to Blink Dev mailing list in 2013. So, and the first Chromium patch by Takashi-san over here happened in the same year. So all the history is happening like in these people. So I'm not sure when we set the Blink launch process in place, but this is how a normal feature launch should look like. You have to talk about the spec discussion, then we send out this intent of the implementation, then we ship the feature later.
Yeah, but this almost happened during the Blink fork.
Yeah,
yeah, so
yeah, I remember that. Yeah, it was interesting. Then 2013, Audio Working Group actually encountered the first roadblock. This was a bad news for the group. W3C TAG is a technical architecture group, and it is a special working group in W3C that provides technical consultation to the other working group. So the TAG published the design review on the Web Audio API specification. That happened in 2013. And the result was not really happy. It's maybe kind of understatement, but yeah. It means that some parts of the spec needs a significant surgery so it could transition to the next phase. Tech raised multiple critical issues on the spec, but the most important, most problematic part was the script processor node. Everyone knows that, right? If you're working on the web, if you work on the web music or web audio API, script processor node is kind of a very valuable tool, right? But it has some design flaw. Let me expand a little bit on that. There was a visible data race in its design, so it's bad, and it rendered the user extended audio node as a second-class citizen. So it cannot be better, or it couldn't be treated just like a native audio node, and that was a problem. But I mean, writing JavaScript code is really fun. It's really almost impossible to stop that. So once you have this escape hatch to developers' hand, things will just blow up. That's what happened with the script process node. But because it was the only way to extend the functionality of a Web Audio API by writing JavaScript code, and all the people just started working on it. This is a problem because the tech pointed out the script process node is a big problem for the Web Audio API, but it quickly became one of the most popular features in Web Audio API, right? And so the lack of extensibility of API was I think it was a big problem for Web Audio API because we gave this script process node to developers, but now tech is asking us that deprecate this feature. So we have to actually take the feature away from the developer's hand, and that was not a great move. And in that way, Web Audio API became kind of a lack of extensibility. Because without script processing node, there is no way to extend the functionality of Web Audio API. And so working group had to come up with a resolution for this script processing node situation. So working group, the initial attempt to address it was a proposal called Audio Worker. It is also proposed by Chris over here. And it later became the fundamental of the audio workload design, which is now accepted as an official part of the specification. The problem with that proposal is we did not have a proper infrastructure for it. It was a really solid and interesting idea, but the problem is, let's say you have something called the audio workload node. Audio node is very small piece of functionality that you can combine with multiple audio nodes to create the audio graph. But let's say every time you create this audio worker node, it will spawn another like background thread to render the audio. So when you have like 10 audio worker node, then you're gonna have 10 threads running in the background. And that doesn't really work out well. It's going to be hugely complicated if you somehow want to aggregate all the rendered audio data into one place. It's going to be a huge problem. So impedance mismatching, that's I think how you put it at some point, I think is really proper. So eventually the working group stopped pursuing this idea because of the lack of proper infrastructure. But like I mentioned, the skeleton of this proposal, audio worker proposal, it significantly influenced the actual design of audio workload. That's what I will talk about next. And that leads to the second phase of the timeline, which is from 2016 to 2019. So almost 3 years after the tech review, Ian Kilpatrick, one of my colleagues at Google, and he pioneered the new feature named Worklet. And in short, it is more of a lightweight version of a web worker. So the weight and the scale of Worklet actually sounds like a very good solution, very good infrastructure for this audio worker proposal. So the idea is to use each audio worklet node instance will share a single thread and single global scope to process the audio, and its story works out. So as long as a node instance is a part of the same audio graph, and it will share the same thread, and there's no overhead or whatsoever. I think it was really right decision to make at that point of time. So the proposal was accepted by Audio Working Group. Now it became, as you know, now it became the part of the Web Audio API spec. And this practically solves the core problem raised by W3C tag. So then all the more good news is following up. The working group put the spec up for another round of review from tag, and now this time tag said they're happy with the resolution. So that helped us to move forward. And right after the stepping from the tag, and Chrome actually shipped the audio worklet behind the experimental flag, and that's M63. It was a really exciting moment in many ways, like for me at least, because audio worklet became available, and also the other cutting edge features like WebAssembly and shared array buffer, they all suddenly became available almost like similar time around. So a lot of audio enthusiasts, a lot of audio developers just started to jump in and started doing things that had never been possible on the web. So it was a really inspiring moment. And more exciting things followed. The Propelhead. Do you know this software company? They're a Sweden-based company. They are the maker of software named Reason. It's one of the most prominent digital audio workstation in the pro audio industry. They actually launched a synthesizer that runs in the browser. But unfortunately, I just visited their website, and some of them was a little bit broken. But I can show you here. So let me Google it up. Okay. So this is their project. And if I click this, this is supposed to be full screen, but somehow now it shows like this. But let me press a couple of keys. So this is actually a great demo to play if this is not broken. But anyway, this was a very interesting thing. I think it was a very groundbreaking example of what audio worklet and WebAssembly can do. What they did is they already shipped this synthesizer in the Reason software era, and this synthesizer was written in C and C++. What they did is just compile this entire code base into WebAssembly, and they just throw that code into the audio worklet. So they didn't do much of writing JavaScript to create the synthesizer. So it was a really newly developed environment for this kind of synthesizer. It also suggests a new point, new direction in terms of marketing strategy of a music software, because traditionally what we do in pro audio field is we have some demo version of installer, so you can download it and install your system as a VST plugin and try it out for a couple of days. If you don't like it, you can just uninstall it. That's how we've been doing for a while, right? But this actually changes that. You don't have to install anything. You just go to a URL in the browser, then you can try it out, this new synthesizer. Then if you like the software, you can buy it after. So good. This is a good and healthy pattern, I think. And more good news is Web Audio API transition to candidate recommendation. It's the phase right before the graduation. And more good news in 2011. My friend Don Turner from the Android real-time audio team and myself, we gave a little talk at Google I/O this year, and the recorded session is available on YouTube. But in short, we demoed how you can use the same C++ source code to build a synthesizer in the Android, and also build the same synthesizer in the Chrome browser. So we shared the same source code. We started from the same source code and built one from Android and one from the Chrome. And also we even did a cute jam after we built the synthesizer. On the stage, it's compiling source code on stage is super fun, by the way. So here's those cute jam.
Basically, because we've got a big sound system, so why not?
Yeah, and Don will be playing the bass line, right? And I'll be playing the lead synth with arpeggio activated. So let me change my setting real quick. All right, I think you're ready for the jam. You ready?
Okay, yep.
Maybe so this is too small. Embarrassing to watch this again. But the thing is, this wasn't really coordinated jam. I think the more important and interesting part is before the jam. So if you're interested in like this new kind of workflow, like sharing the same source code for a synthesizer and deploying the synthesizer to both platforms at the same time, we actually did a live coding session. So it is much easier to follow what's happening when you see the code is like being typed in the screen. So I kind of recommend that part, not the jam part. Okay, let me go back to the slide. Okay. And Ableton, which is a big name in the pro audio industry, they dropped a new project on the web, and it is a really well-made tutorial on the sound synthesis. The name of the project is Learning Synths, so you can just Google Ableton Learning Synths. And how many of you are aware of this project actually? Oh, okay, so this is good news. I really recommend you to try this out if you're interested in how to create a synthesizer, or if you're interested in how to make sound with computer. Yeah, this is a really nice made tutorial. All right. So that actually wraps up my review on the history of web audio. We just put a lot of pins on the timeline, but what do we have now after those 9 years? So there are a few things we've done well.
ちょっとですね、今Google スライドで同時通訳をしてくれる機能があるそうで、それをちょっと今オンにしてもらおうと思ってます。少々お待ちください。
Oh, that's even more embarrassing. Hello. Hola. Hello. Should I change it to Japanese? Is it possible to change to Japanese?
誰か知ってます。文字起こしだけか。
Maybe just picking up the what is still useful to listen. So
Okay. All right. Was I speaking too like small?
yeah, maybe same speed is fine, but caption will help people to understand.
Okay. Yeah.
If you can continue to listen.
I think I activated the caption, but I'm not sure actually it's showing up here.
Just activate it.
Press it again.
Yeah.
Hey. Okay. All right. Yeah, thanks so much. Yeah. So there are a few things we've done well. It's not really to brag about, but the number is not small anymore. Because from the like entire web traffic through the Chrome browser, web audio actually takes like from 3 to 4%, so it's not really trivial. I think it's quite big number actually. If you consider the daily active user is about 2 billion, I think that's what I heard, yeah. So 3%, 4% of 2 billion is not that small. And also, this is what I found recently, and the daily activation number of audio contexts. So number of audio contexts is being created per day is 25 million. That's also quite a big number. So everyone, all around the world, they are creating audio context 25 million times per day. And valuable lessons learned over 9 years. The extensibility matters. That's how you empower developers, and when developers empowered, the ecosystem will grow, and that's how you create this healthy loopback feedback system. And also making unfounded assumption is very dangerous, and that's kind of what we learned in the early stage of spec discussion. Also, we want to make less magical, but more introspective. So that's one of the problem of a lot of APIs. If the API is too magical, it looks very like interesting, and you want to use them. But in the end, less magical features are kind of better because it's more predictable and deterministic, right? Also, we have to value users' feedback, collect early feedback as much as possible, and iterate and work with developers. That's super important as well. I'm saying this because these days, when someone shows up the issue track of a web audio API and they say, hey, I think this is a problem, we need to fix that, but every time that happens, working group people kind of said like, well, we know that's a problem, but I think it's too late to fix that, so we might deal with that later in the version 2 or something like that. So that's not really a great pattern for a working group or for developers. And the last point here, yeah. So we have actually a diverse ecosystem. That's what really we are proud of, because let me show you. So this is BandLab. We have a lot of several working digital audio workstation on the web freely available today. This is one of them. BandLab, and also we have a Soundtrap, which was featured in Google I/O in 2011, I think. And yeah, and also we have a bunch of other things, like audio tools, which is super popular in the Flash community. Actually, this was really interesting because they had an interesting conversion, because audio tool was originally based on Flash. So basically, what they did is just port their Flash code into the WebAssembly, and now they are running the WebAssembly and audio worklet. And M2 Studio is also a very interesting example. It's a fully functional, fully fledged digital audio workstation that runs inside of a Chrome browser. But the interesting thing is, this is what I used for the jam session that I just showed you. You hear the background drum sound and everything, right? That's from M2 Studio. Its strength is basically it has a really nice set of drum loops and sampled instrument. It comes with a lot of library and packages, so you can just use it for the instant music making. And last one is Foundation. This one actually featured in Chrome Developer Summit last year because it uses multi-threading WASM. It was very shocking, and they achieved 300% of a performance boost by using multi-threading in WASM. And they also had a very interesting transition path because the Foundation app was written in Nagel. I'm not sure it's familiar with everyone here. It's a deprecated technology, so you should not use it anymore anyway. But the Nagel is short for a native client. It's a limited set of API, C++ API that you can use to create the plugin for Chrome. So it's already sounded really bad, right? It's a native code, and it's a Chrome-only technology, so you should not do that. So our WebAssembly team and the Web Audio team proposed a transition path for them, how about using WebAssembly and WebWorker and an audio worklet to port your native client app into HTML5 technology? And they did that. And it worked out really well. And let me go back to a few slides. And also we have a ton.js, which is the most popular library and framework for web audio. And also we have Ableton's interactive music tutorial, and also we have something called the Chrome Music Lab. And this one is really popular in early stage of music education. There are a lot of interesting YouTube videos around this one. And also finally, we have something called a Web Audio Conference. This is a very interesting venue because we can get a different set of feedback from this event. This is a very academic-centric event. You get to see a lot of interesting experiments and some interesting benchmark. And sometimes it's surprising to see from like industry to what's happening in the academia. And this is a really good venue for that. This time, the conference will be in Norway, an exotic place. And things we could have done better. This is non-exhaustive list of things that we could have done better. We still can answer this question with 100% of confidence. Who is this for? Who is this web audio API for? Is it for game developers? Or is it for pro audio people? It's really hard to answer that. Also, there's a big conflict of interest between performant audio system and the garbage collection. They always fight each other. The garbage collection usually a world stuff event, and that doesn't really work out for this glitchless audio system. I think it's kind of a very fundamental problem of a web platform and task scheduler at all. Yeah, you're laughing. Okay, that's a good sign. Also, Web Audio API is based on the memory resident processing model. That what I mean by that is you have to load up a large amount of PCM audio data first, like completely on the memory first, so you can actually interactively control those data. So if you're dealing with a large scale audio data, like 4 gigabytes, 8 gigabytes of audio data, there's no way to load those data into the memory like at once. So that has been a problem for game audio developers because they want to play really like the long background music or like long atmospheric music, that kind of things. It doesn't really work out with the Web Audio API really well. Also, the Web Audio API largely lacks a control over the audio device. So audio context is somewhat is magical, and the rendering model is kind of very rigid. That means Web Audio API always render by 128 sample frames. So anything out of that ordinary, you're gonna have a bad time actually. And as you already know, we already have some cross-browser compatibility issue with Safari and Firefox and Chrome in terms of a Web Audio API implementation, and the list goes on. But these are the most critical problems that we had to deal with, and it's on top of my head. So the question is, what can we do better? Obviously, from a working group perspective, the answer is always yes. So I guess now I'm ready to talk about what's ahead of us. What's the next for web audio? So 2 things are on the horizon, but here today I'm going to talk about something called Audio Device Client. This is a new proposal from Audio Community Group. I'm driving the effort. I'm going to talk about this only because it has a bit more details. A lot of things on Web Audio API v2 is still in flux. It's just too early to talk about it. So, Audio Device Client, what is it? It's a work-in-progress proposal, and one of the benefit of this API is device selection and configuration, which we really needed in the line of audio context. So you should be able to set up your own sample rate, you should be able to set up your callback buffer size and more. It will be much more configurable. And it will be a callback-based function like callback API basically, and no abstraction overhead, because a WebAudio API comes with the predefined building blocks called audio node, right? Gain node, filter node, compressor node. The API surface is really large, but we intentionally want to avoid that at this time. So we're gonna make it really a tiny API that only cares about one thing: performant audio rendering. Also, audio device client, it will use a real-time audio thread, real-time rendering thread when the system is permitted and the permission is allowed. And also, it will be web-friendly by default. So here's the kind of a sketch of the API. So first, we start from the media devices namespace. There's a method called enumerate devices. So when you have that, you're gonna have an enumeration, a list of a device that is recognized or attached to your browser, basically. Then you're gonna set up something called constraint token. In this token, you have an input device ID, output device ID, and sample rate that you wanna run, and callback buffer size, and so on. So once you set up this constraint, you can pass that object into something called get audio device client. As a result, you're gonna get client object that you can interact with. So one of the good things of this pattern is you're passing constraint token, and this token is somehow not accepted because let's say you only have a stereo output, but somehow you requested like an audio device with 6-channel output, then it will be rejected. So that's kind of pattern. That's going to be a pattern that we'll be using with audio device client. Then after that, it will be kind of very similar to audio worklet. You can add module, like a JavaScript code of your own. Then you can control the transport by calling start and stop method. All right. So this is the separate global scope that you will run on your own audio code. So you can import some WASM powered audio engine just like that. Then you can define a process function. Then you're gonna pass this process function to set device callback method. Then this process function will invoke like every interval that you set up with a callback buffer size. It's too boring, right? But let's take a look at this in two different angles. First, the layering consideration. So we have something called the audio element. And it's a very high level, it's abstract, but it only provides a limited set of control, and it's stream-based. And then we had a WebAudio API, which is an intermediate layer. It has a large API surface, it's abstract and dynamic and interactive, memory resident, but now we have the low level. So this is kind of equipping the proper low-level layer in the web platform. Also, this is kind of one of the diagrams that I like to show when I talk about audio device client, because macOS has core audio, Linux has Pulse Audio or Jack based on ALSA, and Windows has Wasapi or ASIO driver. So they all have this low-level audio API in all the native platform, but what do we have for web platform? So that's the kind of key points that I'm trying to point out here. So web platform, we like to have an audio device client. So current state of things, we published the explainer, and I also made a talk video from last workshop in W3C Web Games. So there's a video and explainer you can actually take a look. And the discussion venue of this proposal will be W3C Audio CG first. And I'm currently working on a prototype of this new proposal based on WebAssembly. Audio worklet and shared array buffer and worker. And I got it working like yesterday, so I'm going to actually demo in the TPAC next week. The reason why I'm working on this prototype of ADC is it's not going to be perfect, because we're going to be missing a lot of like device configurability and low latencyy mode, a lot of the benefit, but it will be good enough for evaluating the shape of API. So that's why we're doing this. And to answer the question is who is it for? I mean, in the early stage, actually, I reached out a lot of several partners, and they are already very interested into using this ADC proposal. They are namely Audio Kinetic. I'm not sure you're familiar with the name of the company. Audio Kinetic is a creator of a Wise game audio engine. So if you play PlayStation 4 games, they always show up with the Unreal Engine, powered by Unreal Engine, and the next screen you will see this Wise there. So they are a vendor of a Wise game audio engine. They're interested in audio device client, and also Ableton, and the other Pro Audio counterpart. But still, we also welcome your feedback and input as like a third-party developers. So I showed you the proposal. I hope there might be a chance to talk about this after this presentation. And lastly, I'd like to mention the Fugu project, because the audio device client is a Fugu project. It's a part of a Fugu project, and let's talk about it. So what is Fugu? It's a Japanese name, right? Fugu, right? So my description won't do the justice, but in short, we are developing a variety of powerful APIs that fill the gap between the web and the native platform. So this is the mission of the project, closing the app gap. They are powerful, but potentially could be harmful as well. That's if you don't cook it carefully, you might die. That's how Fugu works, right? And there was a Google I/O talk this year about this project, so be sure to check it out if you're interested in how the project is going. Just to clarify, ADC is filling the void in this area. So let's just step outside for a bit. I think I used almost my time, it's already 40 minutes, but so maybe I should just talk about later in the chattings. If you're interested in like special audio, 3D audio that can be used with the VR and XR, please come talk to me. I have some ideas that I can present. So that's about it. That's all I have, and thank you so much for listening.
Hi, ありがとうございました。Thank you very much for your talk. It was really interesting story that Web Audio have for last 9 years. Thank you.
Appreciate that you feel that way.
It was a very interesting talk.
Thank you.
で、今ちょっとキャプションを出すところを説明しておりますので、少々お待ちください。次は、WebXR の、コーチェアをしておりますクリス・ウィルソンから、WebXR AR and VR on the Web というタイトルで、お話をいただきます。よろしくお願いします。
Okay. How do you move it up? Okay. AG, how did you move it up?
Oh. We don't have the options. Which I have an extension. I have an extension to move that to the top.
If you want. That's fine. Okay. Hello. So I'm Chris Wilson. I work on the web platform, a lot of different things. Among other things, the WebXR device API. And as Hong Chen said, I have a long history in web audio and web MIDI as well. I'll try to speak slowly. I have a really bad habit of speaking really fast when I'm talking. So if I'm speeding up too much, raise your hand, wave at me, jump up and down, something, and I'll try to slow down. I do not have as many links in this presentation as Hong Chen did, but the slides are still up. And this is at the end of the deck as well, so you can write it down then or load it, so I don't have to sit here too long. First I wanted to ask, how many people know what WebXR is? Okay, good, then I chose the right level of detail for this deck. I want to start with talking about virtual reality. And virtual reality is all about completely immersing you in a different reality, like strapping on something that hides the real world from you and then replicating a world that you can kind of live in. It replaces your current experience. And it could be a game, it could be exploring a data set, it could be a virtual workspace. You could replace the monitors on your desktop with virtual monitors that are rendered. In the context of WebXR, all of this rendering is using WebGL or WebGL2. This isn't anything really special on the rendering side. It uses the same 3D rendering you use on a flat 2D web page to render onto a flat 2D web page. And of course, I did want to mention you could write WebGL code directly. That's probably not really what you want to do most of the time. Sometimes you do. But there are plenty of libraries to help you write WebGL. 3JS, of course, is one of my favorites. Not only, though, do these libraries usually take care of the heavy lifting of drawing graphics and kind of managing the GL context for you, it also usually, these libraries like 3JS and A-Frame in particular from Mozilla, they integrate very well with WebXR. Like you can say, I want to create a WebXR rendering, a VR rendering in 3JS, and it will deal with all of the details of WebXR. You don't actually have to write to the WebXR device API at all, which is super helpful. And you may also have heard of WebVR and wondered what is WebXR versus WebVR. Well, it turns out WebVR is actually completely deprecated. No one is really focused on WebVR. It was never a real standard. It was kind of something that a community group had been putting together. And Chrome never actually shipped WebVR. You could turn it on with a flag inside Chrome, but we never turned it on by default, and we're slowly easing away from that altogether, and we will at some point very soon remove all the code. Even though Microsoft Edge and Mozilla both shipped WebVR on by default. But there were some shortcomings of WebVR. I don't want to get into the whole list, but WebXR avoids those. It was mostly having to do with like higher frame rate rendering and different numbers of views as well. And the other key thing is that WebXR is really three fundamental pieces. The first two of these were kind of covered in WebVR. So the first one of these is the core of WebXR, which is covers all of the VR level stuff, like being able to have a rendering context, managing the head pose, like getting the accelerometer info or mapping info, tracking info to know which way you're looking at any given point in time, and just kind of enumerating devices and what they can support and that sort of thing. The second module was a different specification, is a different specification now in WebXR. It was also something that we had proposed as gamepad extensions to the gamepad spec in the W3C. We now have a separate module for this, that's a gamepad controller module. And then the third piece of WebXR is completely new, which is an augmented reality module. The interesting part is all this really does today is it has a different mode that says when you render on this device, in this mode, in this session, like paint the real background as well. Instead of having a black background that you draw virtual objects on top of, you have a transparent background. Either render the camera feed or in a number of devices, you actually have a pass-through rendering or a see-through rendering. Now when I talk about virtual reality, the first chunk of this, usually you're using a tethered headset like the HTC Vive or Oculus Rift, or standalone devices like the Go or the Quest from Oculus, or you're using a smartphone VR-based system, Samsung Gear VR or Daydream View, even Google Cardboard, my personal favorite. And any of these devices uses some kind of combination of head tracking, screen display, optics, like even Cardboard has the lenses in it, and controllers for many of these to make you feel like you're present in a virtual space. And you know, you move your head and it feels like you're just looking somewhere else. WebXR actually in that core module, it enables connecting to these devices, detecting what they are capable of doing, managing the sessions on them, initializing the sessions, tracking where you're looking, and just updating a view with the right transform for that. And in fact, you may not even have a headset to view VR. WebXR and the polyfill that I'm going to talk about in a minute support viewing VR worlds just on a mobile device and kind of using the accelerometer and the orientation API to look around. So you can turn them around and that kind of thing. This lets users look around your virtual world even when a headset isn't handy. And this polyfill, by the way, also works on iOS. So this does work on iPhones as well, which is great, including Cardboard. The second piece of WebXR that I talked about was input controllers, and this module builds on the gamepad API in the spec. It adds support for the 6 degree of freedom controllers you frequently have with VR devices, or AR devices in some cases too. So like the Oculus Quest that I have, it has two pointers with it, 2 controllers, and it tracks exactly where they are, exactly which direction they're pointing. And those were new compared to the gamepad API. Gamepad controllers typically don't have those. They also have other controllers, usually like a joystick or a touchpad on the controller itself, and we had to expose all of those. And standard button layouts and the like. So the final piece of WebXR is this augmented reality module, and this spans supporting actually 2 really different scenarios, and we still have a lot of work to do here. I'm going to get into that in a minute. This spans headsets that are pass-through devices like the Microsoft HoloLens or the Magic Leap 1, which actually, the Magic Leap 1 currently ships WebXR. It's a kind of an experimental build, but it is on by default to the browser, which is great. But also smartphone AR, so that you can just use your smartphone and it builds on top of AR Core or AR Kit. And you can use it as kind of a window into reality, and it just uses the camera and passes it through to the screen as the background. And the goal, of course, is to have a common platform API, so you can write an application that is supported on either one of these kinds of scenarios. You don't have to write a completely separate experience. Now, interestingly, augmented reality is really about being able to overlay things onto reality. And if you've tried out AR stickers, that's pretty classic world AR. If you have used apps that put masks on your face or whatever, that's a different type of augmented reality. It's kind of flat facial recognition usually, which isn't directly one of our use cases, but it probably will be in the future, particularly when we start mapping into 3D space. And there are hundreds of millions of phones and tablets out there today that support augmented reality through ARKit or AR Core, and that number grows every day as AR Core and AR Kit move out to other devices. And also, of course, as people upgrade their devices. And with WebXR, we really want to make use of that to say you can add AR experiences to existing 2D websites, just like this example here, where we have a flat kind of Wikipedia-style site, and the user can say, oh, I want to pop the spacesuit out and look at the 3D model and walk around and examine it. So, I want to do a very compressed version, kind of what Hongchen did for web audio, and talk about the status of where this API is. WebXR has been underway for about a year and a half now, I think. We started a working group in August of last year that I co-chair. But I want to talk about when you can actually use this. We are actively building out the final bits of the VR scenarios for WebXR today in Chrome and in Mozilla's implementation at least. We both already have implementations you can play with under a flag. We will both be shipping them quite soon. I think for both of them, I'm fairly comfortable saying before the end of the year, these will be out and on by default for VR scenarios. Obviously, I'm not in control of that for either Chrome or Mozilla directly, but I'm fairly confident in it. And as I mentioned earlier, we already have a polyfill that you can use. And in fact, the polyfill will work on top of WebVR implementations. So if you're running on Mozilla or Edge, or your users are running on Mozilla or Edge, it will work today on one of those devices. Now, for the AR scenarios, for building AR work, the design is a little bit further behind. Especially for how to expose real-world understanding, because part of AR is just being able to have this pass-through rendering where I can make a 3D object appear to float in midair, and I can walk around it and examine it and all that sort of thing. But part of it is being able to recognize the real world, knowing where the floor is, knowing where the walls are so I can stick something to the wall, knowing where this tabletop is so I can set something on it in augmented reality. And those parts are hard. I say hard not because they're fundamentally difficult, although they are, but because we're trying to build on top of multiple underlying systems and kind of unify them in how they can expose these things. So some implementations are there today. You can actually create an immersive AR session on a Magic Leap one today and render things to it. It doesn't have any hit testing or exposure of the real world yet. I think that we're going to see experiments available under flags early next year, if not before, in Chrome and others, and hopefully we'll have those basic AR APIs actually shipping probably around the middle of the year next year. But we still do need some more design work there. And I should have mentioned before, this is a very big group effort. We have a large working group. We have a group meeting next week at TPAC. I think we have 54 people registered to be there. Our last face-to-face meeting had about half that, but TPAC is usually about double, so that's about right. And we have really active participants, key participants from Amazon, Google, Oculus, Magic Leap, Microsoft, Mozilla, Samsung. In fact, I co-chair the working group, and my co-chair is Ada Rose Cannon, who works for Samsung. And I also blatantly stole several of these slides from a deck that she's presenting next week, so I should give her some credit. And since Hongchen skipped over his section, I did want to say audio is definitely a key part of building an immersive experience. The really cool thing is web audio already has a 3D immersive panner node. All that you have to do is make sure that you're tracking it based on which direction the user is looking on their head pose. And in fact, 3JS, and I'm pretty sure A-Frame has this too, they actually build these objects in for you. So if you're using 3JS to build a WebXR experience, you can actually create a sound-producing object in the world, just like attach an audio stream to it, an audio node of some kind, directly to that source. And then it will just sound like it's in the right place to the user. You don't have to worry about it. You don't have to update anything or anything at all. And with that, I'm happy to take any questions. This is My email and Twitter, I'm happy to take live questions as well too. I will forewarn you, if you follow me on Twitter, you'll get random US politics as well as web audio and XR and various other web stuff. And that's the link to the deck again. Yeah.
So,
Do you know any, for example, Oculus Quest, they still use the WebVR, but do you know any plan when they can migrate to the new WebXR based API?
Do I know any plans to of how to migrate to WebXR? We actually have started looking at how we could write a migration guide. A lot of it is pretty mechanical. It's pretty straightforward. Most of the things in that difference are in the setup, like how you create a session, how do you make sure the session supports the right things. Some of those are design choices that are different between the two, that are a little tricky sometimes. Like I work with the Poly team, poly.google.com. They build a library of 3D models that you can access. And they have a WebVR experience. And we started trying to get them to migrate to WebXR. One of the things that WebXR does is it doesn't actually tell you what device you're connecting to. And the reason is because a lot of developers were actually explicitly saying, I want you to run this on an HTC Vive or something like that. And that's not actually useful, right? That's kind of like saying, I will only show this web page if you're on an iPhone. Not really the experience you want to offer your users. So we changed how the API works, and you have to access it differently. You say, I need to be able to render, a VR setup, and I want to make sure you have a 6DoF controller or something like that. So it's not all mechanical. It actually is pretty straightforward though, and Poly in particular I think will get transitioned over pretty quick. But we are planning on writing a migration guide.
Thank you.
Any other questions?
質問ある方いらっしゃいますか?
Okay, thank you.
Thank you very much. はい、どうもありがとうございました。WebXR。今、マイグレーションガイド、WebVR で書いたアプリをどうやって WebXR にマイグレートするかっていうガイドをこれから書こうとしているということをお話ししています。で、いくつかのところはどうも機械的には行えなくて、ちょっと考えないといけないところがあるということなので、そのマイグレーションガイドが出てくるのも楽しみっていうところかもしれませんが、はい。はい、ということで、最初の2つのトークが終わりました。で、今からですね、真ん中ですけども、ショートブレイクとあとネットワーキング、We're gonna have a short break and networking with onigiri and drinks. So, and we're gonna start 9時20分からまた次のセッションを始めたいと思いますので、そうですね、むちゃ長いですね。もしかするとちょっと前倒しにするかもしれませんけども、お声をおかけしますので、よろしくお願いします。で、軽食を食べながらですね、向こう側に展示をして、展示もしておりますので、そちらの方を見ながら楽しんでいただければいいかなと思います。はい、それでは移りましょう。掛け声が難しいですね。
先ほどあちらで展示をしていたハードリードと申します。この LT なんですけど、スレックと言われるゲーム向けのイベントで、ゲーム開発者向けのイベントで、IKKOさんからプレイキャンバスのチームに対して少しお誘いをいただいたので、この15分間をいただくことができました。ありがとうございます。で、まず自己紹介ですね。羽賀龍斗と申します。で、GMO クラウドという会社で、プレイキャンバスの推進室と言われる部署に所属をしております。で、配属をされたのは今年の4月からで、もともとフロントエンドのエンジニアをやっていて、リアクトとかリアクトネイティブとかでスマートフォンアプリとかを作っていた経歴になります。で、今年の4月からプレイキャンバスをフロントエンドのエンジニア目線で広げるために活動しております。Twitter のアカウントとかはこちらになります。で、あと今回のトークなんですけど、QR コードがもしかしたら頻繁2回ぐらい出てくるので、もしよろしければ QR コードを読める状態にしていただけると嬉しいです。で、今日話すことですね。まず、プレイキャンバスとは何ぞやというところと、プレイキャンバス今知ってるよって方っていらっしゃいますか？結構いらっしゃいますね。大体のイベントでほとんど手が上がらない状態なんですけれど、今回のイベントはかなり稀だと思っています。で、今日の、あと他には今日の展示物についてですね。と、次にプレイキャンバスを使用して WebXR、VR と AR の始め方について話させていただきます。で、今日これだけは伝えたいってことは、プレイキャンバスでは結構自分の作ったものをブラウザだけで簡単に世の中に出せます。で、あと、あまり多くの人がやってないことを WebAR とか XR とかをかなり簡単に作って世の中に出せます。この2つを言いに来ました。で、プレイキャンバスとは何かと言われると、WebGL のゲーム開発エンジンとなります。で、3D に強くてカジュアルゲームとかリッチなコンテンツとかも幅広く作ることができます。で、クラウド型の開発エンジンとなってまして、ウェブブラウザさえあれば、インストールなどは必要なしに、ゲームの開発から公開までをすることができます。で、エンジンの中身は全て JavaScript でできていて、あと、エンジン自体はオープンソースでなっていますので、誰でもソースコードとかを見たり、改善とかをすることができます。なので、ビルドとかも挟む必要がなくて、即時性が高いのが特徴になっています。で、こちらが実際にプレイキャンバスで作られた BMW とかのデモになっているんですけれど、こちらはブラウザだけですね。下にアクセスされているのが Firefox でアクセスしたものと iPhone で6でアクセスしたもので、ほとんど遜色ないもの、動きが出てきていると思います。で、こちら URL が表示されたと思うんですけど、こちらは URL だけでアクセスして見ることができます。で、プレイキャンバスの開発環境なんですけれど、こちらのようにビジュアルエイターが存在していて、こちらがゲームを起動した時の画面になっているんですけれど、で、こちらも全てブラウザで動いています。で、実際の開発風景みたいなものを録画してきたのがありますので、そちらを再生させていただきます。こちらはスレックと言われるゲーム開発者向けのイベントでワークショップをした時の説明動画になります。このように 2D のゲームを作っているデモになっています。で、スプライトのアニメーションなどもこちらでプレイキャンバスのエディター上で作ることができます。で、作ったゲームは全てウェブブラウザで遊んで、あと配布まですることができます。で、あと 3D モデルも使用することができます。で、3D モデルの使用なんですけれど、FBX や OBJ データなどはドラッグ&ドロップすることでインポートすることができます。で、インポートされたデータなんですけど、こちら JSON に変換をされます。で、テクスチャーもディフューズとかスペキュラーとか、そういう感じの設定をすることができるので、プレイキャンバスエディター上で光沢とかを設定することもできます。で、プレイキャンバスで開発できるものなんですけれど、3D ゲームは FBX や OBJ データをインポートすることができるので、 作ることができて、あと 2D ゲームとかもスパインとか言われるソフトウェアで作ったアニメーションを入れることができます。あと WebVR は Oculus とか Oculus Go とかを使って開発するサンプルがかなり多くありますので、そちらを見ていただけると作ることができます。今回あと発表させていただくのは Ace Ball というのが最近対応したので、そちらをちょっと後でやります。で、iOS はちょっと微妙なんですけど、ビルドをしてダウンロードすると WebView でエクスポートされたものが落ちてくるので、まあ開発できるとはあんまり言えないぐらいなんですけど、できます。で、Android の場合は PWA とか TWA とか言われる技術を使うことで、今 Google のプレイストアに出すことができますね。で、あと実際に日本で使われている実例とかですと、最近プラチナ X さんという会社が作っているクリプトダービーというブロックチェーンゲームがプレイキャンバスで作られているのと、あとアクセル・マークさんが作っているコントラクト・サーバントというゲームも、またこちらもブロックチェーンゲームになるんですけれど、こちらもプレイキャンバスでバトルシーンなどが作られています。で、あとこちらの、下の方がプレイキャンバスの日本のチームが作ったデモサイトとなっているんですけれど、もしよろしければ後で資料とかをアップロードするので URL にアクセスしていただけると。で、次にプレイキャンバスの VR の開発ですね。で、先ほど展示させていただいた展示物についての説明をします。で、あれは VR のデモになります。で、今回のデモなんですけれど、プレイキャンバスで WebVR の設定をして作った展示物になります。で、Android、iPhone、パソコンなどブラウザがあれば見ることができます。で、今回は Oculus Quest のコントローラーのデータを Ableton と言われるネットワークエンジンを使って同期をしています。で、こちらはあれはお祭り、夏だったので作ったのがお祭りの縁日をイメージして作りました。で、開発期間はこんなもの作ろうかなって言って開発するまでで1ヶ月ぐらいあれば作れました。で、使用した機材としては Oculus Quest と、あとプレイキャンバスと、あと Photon と言われるネットワークエンジンですね。この3つがあれば作ることができます。で、開発人数は2人でもう1人自分の会社のチームの方が来ているんですけど、この自分がフロント側を担当していて、あと 3D モデルを全て一からフルスクラッチで作ってくださった宗方さんがいらっしゃるので、ちょっと準備してもらってもいいですか。で、今回のデモなんですけれど、コントローラーとキャラクターの位置情報を Photon と言われるネットワークエンジンから送信をしていて、それをいろんなデバイスで同じような情報を送って見ることでリアルタイムでレンダリングをしています。で、先ほど箱スコをあれですね、配させていただいたんですけど、もしよろしければ後であっちにあるので好きなだけ取っていってくれると嬉しいです。今70個ぐらい、55人ぐらいの会場に今70個ぐらいあるので、1人 1.3 個ぐらい平均して持っていっていただけると帰りが楽になります。で、あと WebVR を動かす際にちょっと iPhone の方は設定をしないといけないんですね。で、それがこんなような設定をしていただく必要があります。で、次にデモの QR コードを流してこんな感じで動くんだよってことをやらせていただこうと思うので、もしよろしければこの設定をしておいていただけると嬉しいです。で、設定の方からサファリを開いていただいて加速度を測れるようにしていてください。で、デモなんですけど、こちらの QR コードを読んでいただけると、先ほど読んでない方ももしよろしければで、今あちらの宗方が動いてる動きが多分皆さんのスマートフォンに全てに同期をされてると思うので、皆さんが一つのロビーに対してワールドに対して入ってるイメージになりますね。なんか物とか投げれますか？なんか見えないですか？これ見えてますかね今。 あ、見えてますか？で、なんか物とかぶん投げると、そうですね。なんか回転してできますか？回転できますか？そうすると皆さんの端末で回転してませんか？じゃあ、物なんか投げてください。なんか、なんか、ゾウさん投げましょう。このような感じのものがプレイキャンバスで作られております。で、あと、じゃあ、これどうやって作っているかというと、ブラウザの情報をすべて取っています。で、ナビゲーター、JavaScript になってしまうんですけど、このような形でナビゲーター .GamePaths と言われるものから情報を取ることができます。で、Oculus の場合は左右それぞれの状態が入っていて、どんどん下にパッドの中の構図をたどっていくと、コントローラーの加速度とか回転とか位置情報とかを取得することができるので、今回のものは、あとどこのボタンを押しているかとかを判断することができます。で、少し日本語の情報というか、あんまり情報がなかったので、この Oculus のコントローラーをデバッグする方法をちょっとだけここで紹介させていただきたいんですけど、Oculus Quest の開発者モードをまずオンにして、その後、物理的につなぐ必要があるんですね。で、その後、Chrome でリモートデバイスをデバッグするという機能があるので、その機能を使っていただくと、Oculus での開発が結構スムーズになるかと思います。誰にも聞く環境がなくて、その概念を知らないで結構ずーっと自分で HTTP とかのなんかサーバーを立ててホストして結構頑張っていて、ちょっと最近知ってって思ったので、ここで共有させてください。で、あとプレイキャンバスでの開発なんですけれど、この情報を見たりするのはちょっとパソコンとつなぐ必要があるんですけど、プレイキャンバスは基本的にビルドを挟まないで更新が可能なため、プレイキャンバスで開発しながらOculus でビルドそのままリアルタイムで更新がされるんですね。で、位置の調整などは Oculus で確認しながら開発をすることができます。で、あと VR の画面に入ってないと Oculus のコントローラーを取得できないっていうのも少しハマりポイントなので、こちらを注意してください。で、VR の画面に入るためにはユーザーからのイベントとかを駆使してちょっと入る必要があるので、そこら辺を VR で開発する際には覚えておくと良さそうです。で、結構今回簡単に作るっていうことなので、プレイキャンバスで簡単に VR のものを作るとなるとどうするかというと、まずこの VR のシーンを作っていただき、WebVR 用のスクリプトを追加すると作ることができます。で、今回サンプルプロジェクトのようなプレイキャンバスにはたくさんあるので、この今2つ並ばせていただきました。で、こちら後で資料とかアップロードするので、もしよろしければその時に遊んでみてください。で、プレイキャンバスを使った実際の開発方法なんですけど、こんな形でビジュアルエディターで動かすとリアルタイムに同期をされるんですね。こちらをOculusで見ながらとか開発をしていただけるとかなり簡単に開発することができます。スケールとかを変更する場合もこんな形でリアルタイムで見ることができるので結構面白く開発できます。で、あと、そうですね、プレイキャンバスで WebVR を作る際にちょっと悲しいことがあって、先週新規のプロジェクトを作成という画面がプレイキャンバスはあるんですね。そこからWebVR が少し外されてしまいまして、でなぜかというと、今まで使ってた WebVR のなんかポリフィルがビルドが古かったせいで Android で変な動きがあっちゃったんですね。それを解消するために1週間ぐらい前に今削除されている状態で、スーンって感じなので、プレイキャンバスもあと少しで、できるようになるので、ちょっと待ちましょう。で、あと WebAR ですね、次。で、プレイキャンバスで WebAR を作成する際に簡単に作成するのは AR のスターターキットっていうものを使用するのと、あと ACE ボールと言われるものを使用するものがあります。で、今回はこの ACE ボールについて説明させていただきます。で、ACE ボールとは結構公式サイトから引用させてもらったんですけど、世界初のモバイルウェブ用の AR プラットフォームらしいです。で、表面の検出や照明の検出などができます。で、マーカーレスとマーカーあり、どっちも使用することができます。で、プレイキャンバスで使用するには、またこちらのような URL からプロジェクトのフォークができますので、こちらにアクセスをしていただくことで作ることができます。で、今回次は使用する方法なんですけれど、プレイキャンバスではフォークという機能があるので、 まずこちらの AR スターターキット、先ほどの URL からフォークを押していただくことができます。で、セッティングスから API キーの設定をします。エイスボールの。で、その後、自分の持っているデバイスを認証する必要があるんですね、エイスボールは。で、そちらを押していただいて、あとプレイキャンバスのプロジェクトを起動していただくだけです。で、あとは表示される QR コードを読み込むと、もう動かすことができます。で、実際のデモがこちらになります。これが職場で昨日撮った写真なんですけれど、こんな形で影とかも結構綺麗に動いていたり、ちょっとでかいですよね、キャラクター。こんな形のとかもプレイキャンバス上で、プレイキャンバスのプロジェクトがそのまま表示できるので、ゲームとかにもすることができます。で、こっちのアニメーションとかもプレイキャンバスで動かしています。で、このキャラクターはサンディちゃんというプレイキャンバスの公式キャラクターです。で、プレイキャンバスの後、開発ですね。開発についてなんですけど、WebVR は基本的比較的簡単に作ることができます。で、ちょっと今エディターがごたごたしてるので、そこは少し1週間ぐらい様子を見た方がいいかなと思います。で、WebAR については、エイスボールを使用するとかなり自由度の高い AR を作ることができそうです。で、あと、プレイキャンバスのゲームが一通り動くので、ゲームとかも作ることができます。あと、プレイキャンバスのサンプルプロジェクトが多いので、やりたいことに合ったプロジェクトをフォークして開発するとかなり簡単に開発をすることができます。ありがとうございました。少しだけ宣伝をさせてもらいます。技術書店というイベントで9月22日にプレイキャンバスの本を自分が書いたので、もしよろしければお買い求めというか来ていただけると嬉しいです。広げていきますので頑張ります。ありがとうございます。
はい、ありがとうございます。何か質問ある方いらっしゃいますか？ Do you have any questions?
使ってるファイルなんですけど、
はい、
JSON に変換されるって言われてたんですけど、これから先って JSON と GLTF とどっちがメインストリームになるでしょう？
ちょっと変わります。
はい、3D 担当なのでちょっとその辺のことをお話しします。基本的には、FBX がメインとなってるんですけども、拡張機能みたいな形で GLTF と GLTF2 を読み込むことが可能にはなってるんですね。はい、なので、使えないわけではないんですけれども、多分主流としてはまだ FBX の方が、しばらく続くんじゃないかという形なので、推奨しているのは FBX というなっています。
すみません、あんまり技術的な内容の質問じゃないんですけど、GMO さんってなんかプレイキャンバスと関係があるんですか？
販売代理店って感じですね。はい。
すみません、ありがとうございます。
一応広い意味でアジアリージョンを担当している形なので、はい。
はい、そうですね、アジア担当ですね。うちのチームは。
すみません、さっき最初の、JSON なのか、もう一つなんてGLTF. So, Chris, do you know the file format about GLTF and JSON? They are using both of them right now, but the question was which one gonna be the next format for it? Do you have any ideas?
So I believe that GLTF will in the future become sort of a default interchange format. I don't expect to see like native GLTF loading and saving APIs for some time though. So don't panic. Don't drop everything with GLTF today. I think anything that you can load and
so how about JSON? Is that going to be converted to JSON, and is it going to be a usual format for it, replacing of GLTF?
I don't think that JSON would probably replace GLTF. I think GLTF is fairly efficient for packaging up 3D assets, and it will probably continue to see adoption over time.
Okay.
Yeah.
Alright, thank you. ということで、GLTF の方、GLTF は便利なので、多分 JSON になることはないんじゃないかというのが、クリスの意見でした。はい。せっかくなのでちょっと聞かせていただきます。Thank you very much for your opinion. 他に
Sorry, just a comment for Chris. Chris's comment. As you know, we are now having a proposal on incubation group of WebXR about having some API to load GLTF or some other file format built in the user agent. So if you have any interest, please follow that incubation group and proposal repository.
Excellent point. Yes.
OK。今質問してくださったのは同じく W3C のヒモリンという今日は普通の服着てますけどということでインキュベーショングループの方で興味あったらぜひクリスに参加してほしいというそういう話でした。他に何かございますか？はい。ではありがとうございました。
ありがとうございました。
ということで、プレイキャンバスのお話でした。続いてライトニングトークになります。ですね、本日、もしかして消し忘れたかな。本日ですね、3つライトニングトークがあります。一番最初、Web Music API、Web Audio Web MIDI ですね、に関して、Toward the Spread of the Web Music、from Forever 12.0 something like that それから続いて、円を3等分する選手権に、ごめんなさい、僕漢字弱くてですね、これ、捧ぐ、ごめんなさい。AR を使って、ケーキを3等分する方法、by ゴリラパウアーですかね。はい、そして、Web オーディオでは、まあ、その沼の住人と言われている G200kg さんから何か発表があるということで、3つ続けて、まず、フォーエバーナンバーさんからお願いします。
そんな名前だったっけ？
昔はね、別のハンドルでもあったと思うんですけど。
すいません、お待たせいたしました。昔 X サウンドって言ってたんですけど、ちょっとツイッターなんか凍結されちゃって新しいアカウントをしたので、ちょっと名前が変わってます。はい。WebXR の方はちょっと初めまして、Web ミュージックの方は、ほとんどお久しぶりです。という感じで、Web ミュージック API っていう話をしていきます。Web ミュージック API っていうのは、全然存在している API ではなく、僕の頭の中にだけまだある API ですね。 まあ、今日は XR の方がいるので、まあ、どういうことをやってきたかっていう簡単に自己紹介です。まあ、Web オーディオのライブラリを作っています。まあ、そんなにまだ使われてないですが、まあ、それを使ったシンセというか、まあ、Web アプリケーションを作っています。あと、まあ、未だに言ってたら失礼なんですけど、見てくれてる方も結構いるんですけど、まあ、昔 Web サウンダーっていう Web オーディオの解説サイトを作っていました。まあ、2013年ぐらいの作成なんで、ちょっと仕様が古いのと、あと ES5 のコードなんで、ちょっとまあ読みづらいですが、まあ、概要は理解していただけるかなと思います。まあ、Web オーディオ歴、僕はまあ7年ぐらいになるんですけども、まあ、正直7年ぐらいやってて、まあ、Web オーディオどうかなっていう、まあ、あまりこう、まあ、皆さんの感覚と僕の感覚って全然違うと思うんですけども、あくまで僕の感覚では、まあ、なんかこう、他の、まあ、HTML5 って言われた頃に出てきた、例えばキャンバスとか、あと、まあ、いろいろなんかその時に API で出てきましたけど、まあ、それらの普及度に比べるとなんかちょっと弱いなっていうのが、まあ、正直なところです。で、なんで弱いのかなって、まあ、自分なりに分析すると、どうしてもその、音響技術のあるエンジニアが今まで参入してきた。でもそんな中で、どうしても作られたものっていうのは、まあ、もともとそのネイティブアプリ、まあ、デスクトップアプリでできたことを、まあ、ウェブに移植しましたよっていう、まあ、ちょっとこう、訴求力の弱いというか、まあ、結局それだったらみんなネイティブ使うよねっていうプロダクトがまあ非常に多かったっていうのがまあ原因かなと思います。じゃあ例えばこういうのはどうでしょうか。これ見たことある人多いと思うんですけど、はい。ここにまあChrome拡張機能があるんですけど、ここでまあちょっと変わりましたよね。まあ、ちょっとうるさかったですけど、まあ、ちょっと音上げすぎましたね。で、まあ、続きに戻ると、まあ、さっきみたいなアプリだと、まあ、簡単に言うと、その YouTube っていうすでに普及しているサービスに対して付加価値を与えるっていう点で、まあ、Web の特性を生かしてるって考えられますよね。だけど、そういうものをどんどん世の中に生み出そうと思うと、やっぱり音響技術のないエンジニアにいかに参入してもらうかっていうのが結構重要になってくると思うんですよね。ところが、まあ、現状 Web オーディオ API って多分音響技術のない人にとっては結構難しい API になってしまっていると思っています。そこでまあ、もっとちょっと簡単にした API を定義したらいいんじゃないか。もちろんその Web ミュージックを広めるために必ずしもこうしなきゃいけないってわけじゃなくて、もちろんライブラリで解決する手段もあるし、まあ、さっきみたいなその Web オーディオエディターみたいなのを作って、まあ、GUI で音声操作したらなんかこう、コードを吐き出してくれる、そんなんでもいいと思うんですけど、まあ一つの回としてまあ聞いていただければなと思います。で、まあコアなコンセプトは3つあって、まず、その、ウェブオーディオはまあ音楽に限定されたものではないんですけども、その事実上音楽に使われてきたっていうことが多いっていうことをまあ考慮して、まあフォーカスを、ドメインするフォーカスをもう音楽に絞ってしまうっていうのがまず1点。で、直感的な API にする。ウェブオーディオ触ってる人はご存知だと思うんですけども、まあ、オシレーターノードとか、一回発音してしまうともう一回インスタント作らないといけないとかいう、まあ結構めんどくさい、なんか直感的じゃない API になってますよね。あとその、オーディオノードをどんどんコネクトしていって、まあなんかこう、音を加工するっていう。あれが音響技術のないエンジニアからすると、なんかすごい変な設計に見えるらしいんですね。そうじゃなくてもっと直感的な API にする。で、3つ目。例えばそのエフェクターとしてのディレイを実装したいっていう時に、じゃあディレイノードだけでできるかっていうとできないんですよね。結局フィードバックさせるためのゲインノードの接続とか、まあドライベットのコントロールのためのゲインノードとか、まあそういう音響知識がないと結局ディレイができない。そうじゃなくても直感的に、まあこれも直感といえば直感なんですけども、音響技術がなくてもそういう複雑な音響処理ができるようにする。っ っていうことで、こんな API だったらみんな簡単に使えるんじゃないかなと思ってちょっと勝手に考えてみました。仮でなんでもう本当にほぼ説明なしで多分できることなんじゃないかなと思います。で、X Music っていうのでシミュレートしてみました。最後ちょっとだけ時間あるんで、デモをしてみます。デモ自体は別に何も新しいことを やらないんで、直感的に例えばピアノで発音したいと、アナライズしたいとかで、コーラスとディレイをかけるんですけど、かかってます。音楽なんで楽譜も出せたらっていうことで勝手に作ったんですけどっていうのができたらなっていうのが僕の考えというか、ウェブミュージックの普及に向かってやれることかなと思いました。以上です。
ありがとうございます。何か質問とかあったりしますか？ Do you have any question? Okay. So, next one. 円を3等分する選手権に捧かる。これすごい楽しみだったんですけどなんか今日いらっしゃってないようなので、本当？すいません。はい。ということで次のG200kg さんによろしくお願いします。ですね、Web Music Developers JP っていうコミュニティあるんですけど、2014年、3年くらいからかな、Google さんと一緒にハッカソンとかやらせていただいていて、でその中でですね、ラスボスっていうなんか称号を与えられる人たちがいてですね、でそのラスボスっていうのはなんかもう変態な人たちですごいアプリケーションを作ってくると。でなのでその Web ミュージックハッカソンで一番最初にそういうアプリケーションを見せといて、あれよりすごいものを作るんだっていうなんか意識づけをしてみんなに一日把握してもらうっていうことをしてたそのラスボスの一人、多分初代じゃないかなと思うんですけど、he's the big guy in the web music community in Japan. 準備大丈夫ですか？でなんかちょっと待ってということなんで、いろいろなところの音楽系のイベントには必ずいらっしゃる感じなので
いやいやそんなことはないです
アナログシンセとかそういうなんかごちゃごちゃしたもののところには必ずいる方なので、会いたかったらそういうところに行っていただくと必ず会います。
音量はどれぐらいでしょう？はい、ちょっとはい、G200kg 深夜ガイドと言います。よろしくお願いします。一応ですね、ウェブオーディオ系のイベントにもよく、出ていたりしますので、今日は一応ウェブサイトですね、G200kg.com っていうサイトをやってまして、一応音楽系の DTM とかその辺の情報をいろいろ書いたりしてますんで、DTM の用語辞典みたいなものが割と適当に用語を検索すると引っかかってくるというサイトになっておりますんで、もしかしたら音楽系やられてる方見たことがあるかもしれませんという、そういうサイトでございます。 で最近はウェブオーディオ系のアプリケーションに結構いろいろ書いてるんですけども、いくつか書いてまして、例えばいわゆるモジュラシンセサイザーですね、ウェブモジュラっていう名前ですけど、もう結構もう古い、ウェブオーディオ API の初期の頃に作ったやつとかですね、こっちがリノイドっていう、これは歌詞とピアノロを入れると歌うっていうウェブアプリケーションです。ちょっと興味があったら後で探してみてください。それからこれはライブイッツっていう、これはライブパフォーマンス用のアプリケーションになってまして、ここで基本的にはパソコンだけでそのライブパフォーマンスをやるっていう、なんか弾くんじゃなくてパソコンを操作してライブをやるっていう、そういうためのツールになってます。ちょっと2、3分だけやりますね。ウェブカメラの映像です。で、これに、ウェブオーディオとかを使います。
Web audio API. Web audio API. Hello. 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 Demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web audio API. Speech synthesis API. WebGL. This is demonstration of Web Audio API. Speech Synthesis API. WebGL. This is demonstration of Web Audio API. Speech Synthesis API. WebGL. This is demonstration of Web Audio API. Speech Synthesis API. WebGL. This is demonstration of Web Audio API. Speech Synthesis API. WebGL. This is demonstration of Web Audio API. Speech Synthesis API.
まあこんな感じでですね、ありがとうございます。基本的にパソコンとブラウザだけで、まあ結構ライブパフォーマンス的なことができますよっていう、そういうものになっております。で、あと、まあちょっと今のやつはもう結構もう古くって、もう何年か前ぐらいに作ったやつなんで、まあその頃からこんなようなことをやってるんですけど、まあちょっと最近の作品も一応紹介しておこうかなということで、まあこんなものを作りかけたりしてます。オーディオエディターですね。ウェブフォームエディターってやつですね。まあちょっと、まあ切り張りとかですね、簡単な編集ぐらいは一応できるようになってます。ただしこれちょっと非常にまだ作りかけで全然完成してないんで、まあいろんなエフェクトとかをちょっといろいろつけようかなと思ったところでですね、実はちょっと挫折してこのまま止まってます。で、っていうのは要するにウェブオーディオ API 結構いろんなことできるんですけど、ちょっと致命的な問題としてまあブラウザのねサンプリングレートがブラウザで決まっちゃうんですよね。例えば Chrome だったら48キロ、まあ昔は 44.1 だったらいいんだけど、どっかのタイミングで 48K に変わりましたね。でその辺をちょっといじるっていうのが非常に難しくって、まあデータそのものはいじったとしても、ブラウザから実際に音を出すところの部分はそのユダヤ人と次第になっちゃってて、まあ、ちょっとその辺がいじれないんで、まあ、なんとなくちょっと想像してた割と本格的なウェブエディター作ろうかなと思ってたんだけど、そこがいじれなくってちょっと今止まっちゃったんですけど、まあ一応なんでものすごく作りかけなんですけど、一応 GitHub に置いておりますんで、参考にしていただくか、続きを作っていただくか期待しております。で、ちょっとさっき言ったサンプリングレートの問題、多分今日は本ちゃんが、説明していただいたオーディオデバイスクライアント、あの辺を使うと多分解決するということで、将来的にはまあこの辺も含めて本当にまあネイティブのアプリケーションと同じようなものがブラウザ上のアプリとして作れるようになるんだろうなということで、ちょっと今後に期待しております。以上でございます。
ありがとうございました。Thank you very much for the lightning talk. And he's saying that he made I think as you know, but he made a waveform editor on the web, but there is some problem on the web browser. Yeah, the sampling rate is defined by web browser. Yeah, and he's saying that he's really happy to hear the audio device API. So yeah, that's all about it. Thank you very much. はい、今日のですね、発表はこれで、全て終わりになったんですけども、あと30分くらいあります。そしてですね、ちょっとすごく簡単なものなんですけども、今日発表していただいた方にですね、簡単なちょっとギフトを持ってきました。それがですね、ティーパックがです。ティーパックって昔はハロウィンの時期にあるんですね。ティーパック is always happen on the during Halloween time, right? And Chris Wilson is very dislike about that. So I think it's moved to before or after. So I brought some gift up about Halloween. I hope it's coming. Oops. So this one, these are Japanese traditional snacks, right? So I have gift for you too. And then